Hello everyone, Mike Aben here with episode 4 of my beginner's guide to KSP. In the episodes leading up to this one, we learned the basics of building and flying a rocket, and in the process of that, we got ourselves into space, but we didn't really stay there, and that's what this and the next episode are going to be about. How do we get ourselves into space? How do we stay there? How do we achieve an orbit? This episode is going to be how do we build something that we know is capable of doing what it is that we want it to do, and then next episode will be about how do we get there. And in the process of building this rocket, we're going to talk a little bit about delta-vee, specifically how much of it do we need? This is going to lead us to building a multi-stage rocket. And in the process of building this multi-stage rocket, we're going to explore some additional VAB tools that we haven't talked about yet. We're also going to talk about attitude control. How is it that we control which way our rocket is pointing and which methods of attitude control we're going to employ in this rocket. But let's not delay this any further. Let's start our game and get ourselves to the KSC. Now, before we get started with building our rocket, I want to make sure to science the heck out of this one. With our last flight, I actually completely ignored science, so this time around, I want to make sure I'm going to collect as much science as I possibly can. So we're going to go into the archives, take a look at the science that we have collected so far. I'm going to draw attention to actually a section down here I haven't talked about yet called Biomes. We talked about situations, but down here says Biomes, and it's blank because it'll remain blank until you've picked one of these bodies here for you to look at. So for instance, if I pick Aben, you can see here that suddenly we got these extra things here. We have the crawlerway, the launch pad, the water, and shores. Now what these are actually locations. The word biome is really kind of misused here because it's nothing to do with biology. So for instance, the crawlerway, we have 2 reports, and our 2 reports from the crawlerway is that we've done an EVA report from the crawlerway and we've done a surface sample from the crawlerway. But if I go to the launch pad, you can see I've also done an EVA report and a surface sample from the launch pad, but I've also done an atmospheric scan from the launch pad, I've done a crew report from the launch pad, I've done a mystery goo and a temperature scan from the launch pad. So clearly, if I take these things to different locations, even though I'm still on the shore, I can still do these experiments once again. So I want to be thinking about now not only situations, but also biomes, or if you like, locations. And on each of the parent bodies, Aben in particular, there are tons of different locations that are out there for you to explore. We've only barely gotten away from where the Kerbal Space Center is. So I want to be thinking about that. Now let's take a look. Let's close this off and take a look here at our experiments that we've done. We've done crew reports, EVA reports, mystery goos, surface samples, temperature scans, atmospheric pressure scans, and we got some science from recovering the vessels. There's one more new piece of equipment that I have. I now have what's called the Science 9000 Junior or something, or sometimes I'll refer to it as the materials bay. I'll mix those up all the time. What I want to do is make sure that I can, it's a lot of science, I want to be able to do those in all of our situations. So if I think about the situations, I'll first start on the surface landed. I will be in the flying low, in the lower part of the atmosphere. I'll be flying high, and then I'm going to get myself into space, and it will be space low. So that's 4 different situations. I want to be thinking about that. So let's get into the vehicle assembly building and start building our rocket. So once again, we're going to start with the Mark 1 command pod because, well, it is the only one that we have. There are bigger ones we can unlock later, but for now that's all we got. So we're only going to be taking 1 Kerbal, and we're going to make that Kerbal a pilot to help, so that Kerbal will help us in our piloting. And right away we're going to put on a parachute so that we don't forget. I like to do this the very first thing, so the last thing you want is to be on your descent and finding out, oh my gosh, I forgot the parachutes. So far, no different than what we've done in the past. Next part is something that's going to be different. Last episode I talked about when we first got into space, well, how do I stay in space? And I hinted at the fact that it's all about speed. We need to build up a lot of speed. When you are in an orbit, you are going fast. That's how you get there. And when you come back down into the atmosphere, you're going to be shedding that velocity as you interact with the atmosphere, and that's going to generate a lot of heat. Things can explode under those circumstances, so we need to protect our capsule and, more importantly, our pilot inside. We're going to go to a new tab here called Thermal, and under here is a number of parts, but the two I want to draw attention to are right up here. They're heat shields. There is a 0.625 meter heat shield and a 1.25 meter heat shield. Clearly this one, there's one smaller, one's bigger. We need the bigger one for this capsule, so we're going to stick that on the bottom, and that is going to protect our capsule from the heat that's generated as we re-enter the atmosphere. Very important part if you're going to be working from orbital velocities. Okay, next we need to attach this to our rocket, but we want to be able to detach it, so we're going to go to coupling. We're going to pick the TD-12 decoupler. We're going to stick that down there on the bottom. Beautiful. And then we're going to go to another new part. Underneath there is another tab called Payload that we've yet to look at. And there's a part in here called the Service Bay. We're going to put the Service Bay right under here. We're going to open that up. We're going to take a look at it. What the Service Bay gives you is somewhere for you to stow stuff away. It's a nice little part. There's a bigger one that you can unlock later, and you can fill this up with as many things as you like and be able to open and close the doors and have access to it. And we're going to put in, for the most part, science-y type of stuff. Now, if you notice, the bay itself is actually rather vacuous. It's just a big empty space, and it can be hard to kind of stick things in there. So to give us something to attach things to, we're going to go to Structural, and under here there's a part called a modular girder, and we're going to stick that in there, and I'm going to stick it up right there. There we go. All right, and you might be knowing, oh, it's kind of sticking through the bottom. We're going to deal with that very, very soon. Right now we're not going to worry about it too much. Okay, let's start putting stuff in here. Let's get into science. So first of all, under science, here's our sciencey gizmos. And what I want to do is I want to do a mystery goo. Now, I've done a mystery goo down on the launch pad. I've done one in the lower part of the atmosphere. I'm going to be going now to the higher part of the atmosphere and into space. So I want 2 mystery goos. Remember how these work is once you do an experiment with a mystery goo, unless you have a scientist to reset it, you can't do another one. Again, we're not going to have a scientist, we're going to have a pilot. So instead, to kind of make this all work, we're going to carry 2 of these. So I'm going to select two-way symmetry down here on the bottom, and we're going to put 2 of them right there. Now, I can actually rotate this with keyboard controls, but I want to show a new set of buttons that we haven't talked about before. Up here towards the top left, we have a set of buttons. The first is the place button. That's sort of the default one that you use to place your things where you want it to go. I'm going to go to the third one here, which is a rotate tool. And if I click on that and then select this part, notice that this sort of set of axes come up, and I can take this and rotate the part that way. So it's a nice little, let's go back to the place tool, nice little part, nice little tool. The keyboard controls work well too, but that one's nice for being, you know, even more precise. Okay, more science, more science. We're going to get a thermometer. The thermometer we can run as many times as we want, as long as we keep getting the science out of it. So we're going to just put one of those on there. There's not a reason for more than one. And on the other side here, we're going to put a barometer right there. Excellent. The other thing I want to put in here, I'm going to put in some batteries. So I'm going to go to electrical. There are some batteries here. I'm not sure how many batteries I need. In fact, this will likely end up becoming overkill, but I'm going to put 4 of them on here. Mostly, again, for look-see. So we're going to stick this on right about there. Now, if we take a look at this, if I close the doors, notice how the batteries are sticking out. I don't like that. That's an aesthetic thing that really bothers me. So we're going to fix that by using another one of the tools that's up here, the Move tool. If I click on that one and click on the battery, it gives me a tool that I can use to move the battery. Now, underneath here, notice that it actually says local. If you click on it, you can change it from local to absolute. And absolute is in reference to the vessel itself. Local is in reference to just this part. Both are useful. Make sure you use the one that you need. Here I actually want the local because I want to just shove this battery in further. We're going to take off the snap, so we're going to toggle that off so that I can move this nice and precisely. And we're going to just slide this in, and notice all four of them are all going in at the same time because I put them on using the symmetry tools. And that looks a little bit better. Let's go back to the place tool. And there we go. That's all nicely contained. Actually, there's one other thing I want to stick on. No, I don't need to. Never mind. Alright, so that's taken care of that. We'll close that off. That looks nice and clean now. Now, we have one more science part. This is our new part that we've unlocked, the SC-9001 Science Junior. And you will occasionally, you might hear me refer to it as the Materials Bay. You can see here it says Materials Bay. So if I do, they're the same thing. Don't let that confuse you. Now, as we talked about in the VAB, I have 4 locations I can do this Materials Bay. It works very much the same as the Mystery Goo does. Once you run it once, you can't run it again unless you have a scientist on board. So I'm going to want 4 of these. So I'm going to select one of them. We're going to put it down here on the bottom. And then I'm going to hold the Alt key on my keyboard and click that again, and it creates a duplicate of it. It gives me an alternative way instead of going back to the menu up here all the time. And then I'm going to click on the very top one, hold the Alt key, click on again. I've just copied both of those. That's a quick way to get 4 of them. So there we go. I got 4 of these Materials Bays. Now, I don't like this really ugly space. Remember I said I was going to take care of that? At this point, you might be knowing exactly how I'm going to take care of that. Yes, I'm going to use the Move tool. So we're going to click on the Move tool. I'm going to click that top piece, and we're just going to slide that up so everything looks nice and clean. Beautiful, exactly what I want. So far we have ourselves a pretty nice looking rocket, but it ain't going nowhere. It has no fuel, it has no engine. So let's put on some fuel cans on this. So we're going to go to fuel tanks. We're going to use liquid fuel and oxidizer. The biggest one I have is the FL-T200. So I'm going to put on actually 3 of these. So 1, 2, 3. And now I'm going to go to my liquid fuel engines. I have 2 liquid fuel engines. I can use the LV-T30 Reliant and the LV-T45 Swivel. Now let's take a little bit of a closer look at the stats. The Swivel has a mass of 1.5 tons. And it has a thrust, this first one here is at sea level of 167.969 kilonewtons, and in a vacuum of 214 kilonewtons. Okay, so that's the Swivel. If I go to the Reliant, it has less mass and more thrust. So you might be wondering, why on earth would you want the Swivel instead of the Reliant? Well, there is a reason. In fact, I want the Swivel. We're going to put this down here on the bottom and talk about why I want the Swivel. The Swivel has what's called, if we go down here, a gimbal. The Reliant does not have a gimbal. And what a gimbal does is it allows the engine to rotate back and forth. In fact, that is why this is called the Swivel, I would have to imagine. It has a vectoring range of 3 degrees, so it can rotate in any direction, at most 3 degrees. You might feel like that's not very much, but it actually is enough for you to help you steer this rocket. And that is something I'm going to need. Now let's talk about steering your vessels, what we call controlling the attitude of the vessel. KSP, actually there's creative things you can do, but there are basically 4 ways you have of controlling your attitude. Number 1, while there's no real order to this, what I've already talked about it, is through a gimbaled engine. We call that thrust vectoring. Another way that you have are through reaction wheels. Reaction wheels are very heavy wheels that are spun up using electricity, and then again using electricity we change the axis of that rotation. You can move the wheel around, and as you change the axis, as you rotate that axis in one direction, the vessel is going to want to rotate in the opposite direction. Isn't physics just wonderful? So we have reaction wheels in the capsule, actually right up here at the top. So this now has 2 methods of controlling attitude. The other 2 that are available eventually are a reaction control system and aerodynamic control surfaces, neither of which I have unlocked yet, so we're only going to be using these two. Now, the problem with reaction wheels, or at least these reaction wheels, is although the reaction wheels in KSP are actually rather ridiculously strong compared to real life, these ones are unfortunately placed right at the very top of the rocket. Typically, you would like your reaction wheels to be more towards the center of your rocket, and there are reaction wheels that you can unlock that allow you to place them wherever you want. I have yet to have those. So the reason why the fact that my reaction wheels are in such a bad location is the reason why I want to put in another means of controlling my attitude and why I'm going with the swivel engine. Okay, now this thing is beginning to look a little bit like a rocket. Let's go and take a look at some of their stats. So down here, the little blue number here, the 1,295 meters per second, is the vessel's delta-vee. If we click on the whole tab in the staging diagram, we can actually open up and get even some more information. The delta-vee we're going to talk about in more detail later, and in fact I have videos that spend quite a lot on the math behind it if you're interested in watching those. But what they are your ability to change the velocity of your vessel. In other words, I can change the velocity of this vector by at most, or this vessel by at most 1,295 meters per second. I can make it that much more faster or that much more slower. That is not nearly enough for us to get into orbit. We'll talk about what is an appropriate number for getting into orbit soon. But the other number I want to talk to is the TWR, or thrust to weight ratio. We've talked about this before, and I talked about the fact that, you know, a thrust to weight ratio in order to take off, you need about a good one to shoot for is in around 1.3 or so. This one's 2.34, so you might be wondering, oh my gosh, this engine has so much thrust, you can add a ton more mass to it. Like if I wanted to, I could like, let's put on more engine, look, more fuel. Whoops, let's put the engine back on the bottom here. More fuel definitely increases my delta-vee, and my thrust to weight ratio is still respectable. So you might be wondering, why don't you make this your rocket? Well, because this rocket is tall and skinny, and you're gonna have an adventure flying it. If you want to experience that, build what you see right here and try flying the thing. You will realize that you will have significant difficulties. So that is why we're going to only put 3 tanks, 1 engine, and this is a much more sane sort of a shape, and we'll get our delta-vees in other ways. One last thing I do want to add as well is we talked about structuring this thing more like a dart with your mast towards the top, and you want to have fins towards the back. I'm going to use, actually there's a bigger set of fins that I have unlocked, but I'm going to use again the basic tail fins that I've used in the past. Let's toggle on the snap and put those 4 of those 4-way symmetry there towards the bottom. That will help this thing fly straight. Now let's start talking about delta-vee, because right now this thing doesn't have what it takes to get into space. To get into space, a good target is about 3,600 meters per second of vacuum delta-vee. Now, what do I mean by vacuum delta-vee? Well, if we click here on the little delta-vee tool here, right now our atmosphere is set to sea level. That means this is the delta-vee that we have at sea level. Engines, rocket engines, are the least efficient when the atmosphere is thick, and it's thickest at sea level. So this is actually not a reflective number of how this thing's going to perform into space. We also, if we take a look over here, we have a vacuum button. We're going to click on that, and this delta-vee then changes. Notice how much it changes by. Right, it's now up to 1,646 meters per second. That's our vacuum delta-vee. There is a second button in the middle there where you can actually get it to calculate the delta-vee at any particular altitude between 0 and 70 in the atmosphere. I actually never use that. I always go to vacuum and think about, I want about 3,600 meters per second of delta-vee. Okay, that's to get into orbit. We also are going to use fuel to get back down. Now that fuel is not going to be a whole lot, but you do want to budget for it as well. You want to budget a little bit extra because things don't always go as efficiently as they possibly can. So I'm actually going to budget 3,800 meters per second of delta-v. So we need to add on about 2,200 meters per second of delta-v to this thing. So we're going to get into the solid fuel boosters. I have a new one unlocked called the BACC Thumper Solid Fuel Booster. And we're going to add these on. Now, we need to have a way of detaching them once they're finished off. So we're going to go to coupling, and we now have these TT-38K radial decouplers. And what I'm going to do is I'm going to attach, I don't want 4 of them, I only want 2 of them, like this, onto the side. So there's one on this side, one on that side. We're going to then put on our, there we go, our 2 things. We always got to make sure that this is set up nicely. There it is, that is good. And in doing that, we have just added a stage here that has an additional 1,607 meters per second of delta-v, giving us a total of 3,254 meters per second of delta-v. We are getting close. Now, I would like to improve our aerodynamics. We have here an aerodynamic nose cone. We're going to put these on the top. The second thing I'm going to do is use the move tool. And let's see, do I want, I'm kind of happy with actually where these end, but I want to take these and I want to slide them down. We're going to put this on, take the snap off. We're going to slide these down a little bit. It actually is, why am I doing that? Because when these things detach, they're going to detach with some force, and if you can push the top end away from your rocket, they actually come off cleaner than if you push the bottom end away. So if you actually slide these down a little bit, they come off usually a little bit cleaner. Okay, this is starting to get into our ballpark, but we need a little bit more, don't we? Yes, we do. And to kind of finish this off, all we're going to do is we're going to put on 2 more of these, and all I'm going to do is grab this decoupler right here, and we're just going to move it over to here. I'm going to toggle the snap on again to make sure it all, and we're going to try and make this look pretty good. It's a little bit, oh, I don't know, actually that's pretty all lined up. I like all these to line up here at the bottom. I think I'm pretty happy with that. Now our staging got a little bit confused with that, so we don't want all of these firing off at the same time. We're going to fire off these ones first, so if you hold on there, it highlights which one that is. So that is the lower pair, so we're going to move that down to here. And then afterwards we're going to fire off these ones, but of course we need to decouple the other ones first. So that is these decouplers, that is going to there. Then we're going to decouple these side ones, and at that time we're also going to fire off our swivel engine, and we are now over 4,000 meters per second of delta-v. Nothing wrong with having extra, so we're just gonna go with that. Okay, we got one last thing to take a look at, and it's something we looked at in our first rocket building basics, and that is thrust to weight ratio. This is looking at the first stage. This is our thrust to weight ratio, but it's vacuum, but these are gonna fire off at the surface. So I'm gonna put it back at sea level, 3.34. You know what? I'm not sure that needs to be adjusted at all. We're just gonna live with that. Let's take a look at what's going on with the next stage. Now you want to have a relatively steadily increasing thrust to weight ratio all the way up during your ascent. I'm going to switch this to vacuum because these will be fired off higher in the atmosphere. It won't be sea level, won't be a vacuum. I could fiddle around with the altitude, but I really don't care. Vacuum is just for me a nice consistent thing to go by, but its thrust to weight ratio is 2.69. That's too high. So we're going to take these ones and we're going to tweak that thrust down. I don't know, a little over 2 would be a nice number. Let's see, whoop. 2.06, I can definitely live with that. It's not mission critical or anything like that. And now let's take a look at our last stage. This is going to be the swivel engine that's down here. Thrust to weight ratio of 2.98. Again, a little bit more than 2.06 would be more appropriate, maybe in around the 2.15 range. And if you want, get in and play with this a little bit. Find out what kind of works for you. 2.16, I'm going to go with that. It isn't all that mission critical, to be honest. But otherwise, this thing is ready to fly. So why don't we take this opportunity to quickly go over what we looked at in this episode. We started in the Research and Development Center and taking a look at the Biomes section and talking about making sure to plan the science that it is that you want to collect to maximize your return on these missions. We then got into the VAB and talked a little bit about delta-vee, and specifically the fact that 3,600 meters per second of vacuum delta-vee is a good budget to have to get you into low Kerbin orbit. This necessitated us taking a look at building a multi-stage rocket, adjusting the staging in that rocket as well as the thrust to weight ratios of those various stages. And while we were building said rocket, we also took a quick look at the rotation and move tools. Both of these tools are there to help you place your parts exactly where you want them to be. And with that, make sure to catch next episode where we will be putting this thing into low Kerbin orbit and hopefully collecting a bounty of that sweet, sweet science. I hope to see you then.